Okay, so I'm going to work through a few examples of calculating slope from pairs of points. Over here we have a coordinate plane where we have 6 different points. Point A is at the coordinates 7, 3, so it's 7 for the x-coordinate, 3 for the y-coordinate. The point B has the coordinate -3, -1. C has the coordinate 1, 1. D has the coordinate -4, 5. E has the coordinate -6, 1, and F is the coordinate 2, -3. So I'm going to work through finding the slope between various pairs of these numbers. And right here I have written out the slope, which is equal to m. It's equal to y2 minus y1 divided by x2 minus x1. So the difference in the y's between the points, and then the difference in the x's between the 2 points. So let's start off number 1 here with the slope between point A and B. So I'm just going to start by writing this for here. We have our slope is equal to, okay, so we're going to call point A point 1 and point B point 2. And if you remember, what that means is that for point A here, this is point 1, the 7 is our x1. And then this 3 here is our y1. I'm just going to put the A there to remember that that's that. And then our B here, we have -3, -1. And this is our x2 and our y2, because it is from our second point. And if you remember from the last video that we talked about, it doesn't matter which one you say is point 1 and which one you say is point 2. The math will all still work out correctly. So now we're just going to subtract the y values here. So we're going to do -1 minus 3 divided by -3 minus 7. Okay, so -1 minus 3. We're at -1. We're going 3 less than that, so it's going to be -4. Then we have -3. We're already in the negative. We're going to continue to go down. This one's also going to be negative. So we can just do 7 plus 3, that's 10. So it's going to be -10. And a negative divided by a negative, those cancel out. And then these are both even numbers. So we can divide both of them by 2. And we can rewrite the fraction 4/10 as we divide 4 by 2, we get 2. We divide 10 by 2, and we get 5. So the slope between points A and point B is 2/5. And we can just do a quick check and see that that sounds about right, because it's positive. And if it's positive, then it's going to be increasing as we look at it from left to right. And a slope of 1 is a 45-degree angle. It would look something like this. So we expect anything with less than a slope of 1 to like 2/5, which is 4/10, right? We saw that over here. That's 0.4. Having the slope be a smaller angle. So it checks out. All right, let's look at another one of these. Let's do points C and D. So we're going to find the slope between point C and D. Okay, now I'm going to skip rewriting this over here, and we're just going to substitute in the numbers as we rewrite the formula. So again, we're looking at y2 minus y1. The difference in the y's goes on the top of this fraction. So remember, we're looking at these blue points here, C and D. The first numbers are our x values, and we're looking for the y values. So right here. So since we go from left to right, I'm going to call point D 1 and point C 2. So this point, this number 1 right here, this y value of our second point is our y2. So it's going to be 1 minus the y value up here, 5. And then we do the x values. So the x value of point 2 is 1. And we subtract the x value of point 2, or of point 1, which is going to be negative 4. So I talked about this in a previous video that when we see the minus a minus here, what we want to do is just connect those and turn it into a plus sign. So 1 minus 5 gets us to negative 4, and then 1 plus 4, that is 5. So we have negative 4/5. So if we go over here, we should see that if we were to draw a line from or between points C and D, the line would be a downward slope. And it indeed is. If we look over here, we have point D, we go continue, and it's a downward slope from left to right. Again, we want to stick with that convention of reading these graphs from left to right. Okay. Now let's look at another one here. So we have points E and F, these red points right here. And I forget that some people aren't familiar with this symbol. This just means and, which is just a little 3 with a line through it. Okay, so our slope is equal to, now we have points E and F. Remember, we're going to go from left to right. E is going to be our first point. F is going to be our second point. So let's write our y2, the y value from our second point first, which is going to be negative 3, minus the y value from our first point, which is 1. And then over here we have the x value of our second point, which is 2, minus the x value of our first point over here, negative 6. And remember, again, we have the minus and minus, so we're going to connect those and turn it into a plus symbol. Okay, now negative 3 minus 1, we get to negative 4. 2 plus 6 is 8. So right here, if we ignore the negative sign for a second, both of the numerator and the denominator are divisible by 4. If we do 4 divided by 4, we get 1. If we do 8 divided by 4, we get 2. That's 1/2, but let's bring back that negative sign now. And we are done. So again, let's remember that if we have a negative slope, it should be a downward sloping line. We come back over here between these red points, and that indeed is a downward sloping line. Now, we also can go through and we can compare the slopes of both of these. So if you can see, the slope of the steepness of the line between E and F here, this red one, is less steep than that of this blue one, the points between, or the line between points D and C. And remember, the steepness is going to increase as the slope increases. Now, if it's going downwards, then as the negative number increases. So we see that between points E and F, the slope is negative 1/2, which is about 0.5, or is 0.5, and then the slope between C and D is around negative 0.8. So it's a decent bit larger, and that's why we see the difference in steepness up here. Okay, now let's look at one more example down below. And this will be determining the slope from a line without the points. So I'm just going to draw a line here. So So I know that I made those 2 dots because, as I told you before, lines are defined by 2 points, but we're not going to look at those specifically. When we're trying to find the slope of a line, we're looking for 2 different points that are on the line that match up with the tick marks on here. Like if I look at this spot right here, we can see that this spot on the line corresponds to the 1, 2, 3 on the x-axis, and 1, 2, 3, 4 on the y-axis. So this has the point 3, 4. And then if we can find any other point on here that also lines up nice and clean, we will be able to go ahead and calculate our slope. And we don't have to do it necessarily. I'm going to show a different way that we can do this without just going through and calculating it using this formula. But I'm also going to do it that way just to show that it works. So this point here is at -2 in the x, and it is up 1, 2, 3. So -2, 3. So remember that the slope is just the rise divided by the run. So we can count how many, just by the tick marks on here, we have to go 1, 2, 3, 4, 5, and then, so our run is 5, and then we just have to go up 1 here. So our rise is 1, and our run is 5. So if you are given a line, and you see that it cleanly goes through some of the grid lines to where you can calculate find a point, then you can just count along those little marks and find how far does it rise up and how far does it run between any 2 points on the line. So let's go through and calculate it manually using these 2 points that we identified here. So this is going to be our second point. This will be our first one. So our second y value is 4 minus our first y value, which is 3. This is divided by our second x value, 3, subtracting our first x value, -2. And there's that minus a minus, so we connect them, turn it into a plus. 4 minus 3 is 1. 3 plus 2 is 5. So you can see that both of these methods are in agreement with each other, and they should work in most of all situations that I can think of.